Have you ever just stopped and wondered how AI art generators can conjure up these incredible photorealistic images from just a handful of words? I mean, it really does feel like magic, but it's not. Today, we're going to dive deep into the engine that's powering this whole creative explosion, and it all kicked off with this one revolutionary idea from a 2020 research paper. So let's pull back the curtain and see how the magic trick actually works.
Just look at these faces for a second. They're stunningly real, right? You can see every pore, every strand of hair, every little expression. But here's the thing, not a single one of these people is real. They were literally dreamed into existence by a computer, generated from nothing more than pure, chaotic noise. Like the static on an old TV. This was the moment the world really got to see what this new kind of AI, called a diffusion model, could do.
And that, of course, brings us to the million-dollar question. How on earth do you teach a machine to create a perfect, detailed image out of complete and utter randomness? How do you give a computer an imagination? It sounds impossible, right? But the secret, it turns out, lies in this wonderfully weird, counterintuitive process.
So here's our game plan for this explainer. We're going to start with the paper that kicked off the whole AI art explosion. Then we'll get into this wild idea called the art of destruction, see how the AI learns to rebuild from the mess, and uncover the secret sauce that made it all click. We'll also see why it's about way more than just pretty pictures before we wrap up with the full-blown diffusion revolution it started.
Okay, so our main source is a paper called Denoising Diffusion Probabilistic Models, which came out of UC Berkeley. Now, these researchers didn't invent diffusion models from scratch, but what they did was refine them. They perfected a key detail that unlocked a level of image quality that just sent shockwaves to the entire AI community.
All right, this is where things get really fun. To teach an AI how to create something beautiful, the researchers first had to teach it how to completely destroy it. Yeah, I know, it sounds totally backwards, but just stick with me, because this is the absolute core of how it all works.
At its heart, a diffusion model is a surprisingly simple idea. It's a two-step dance. First, you take a perfect piece of data, like a photo, and you systematically wreck it by adding a little bit of noise over and over. Then, and this is the clever part, you train a neural network to learn how to perfectly reverse that process, to clean up the mess step by step.
So step one is what they call the forward process. And you can think of it like a fixed recipe. You start with a nice, clean image, then you sprinkle on just a tiny bit of random, grainy noise. Then you do it again, and again, and again. In the paper, they did this 1,000 times. By the time you're done, the original picture is totally gone, just lost in a sea of pure static. But, and this is super important, the computer keeps track of exactly how much noise it added at every single step.
And now, for the magic. The AI has mastered destruction. Now it has to learn the art of creation. This is the reverse process, and this is where all the learning happens. The goal is simple. Undo all that damage, one tiny step at a time.
So to create a totally new image, the AI starts with a blank canvas of random static. Then, at each of the 1,000 steps back, its only job is to look at the noisy image and predict the noise that's in it. Then it just subtracts a little bit of what it predicted, making the image a tiny bit cleaner. It repeats this super careful cleanup job 1,000 times, and just like a sculptor chipping away at a block of marble, a beautiful, coherent image slowly emerges from all that chaos.
Now, the artist that's doing all this heavy lifting is a special kind of neural network called a U-net. Its design is just really good for these kinds of image tasks, and for this job, it's been trained on millions of images to become an absolute expert at one specific thing, being a world-class noise detective. It just looks at a noisy picture and figures out exactly what noise is hiding in there.
Now, this general idea had actually been floating around since 2015, but it never really produced amazing results. So, what was the secret sauce? What did this 2020 paper do that just completely changed the game?
Okay, this right here is the critical insight. Before, other attempts tried to make the AI predict the final clean image from any noisy step. But that's an incredibly difficult thing to learn. The absolute breakthrough in this paper was to give the AI a much simpler job. Instead of asking, what's the final picture going to look like, they asked a much easier question. Hey, just tell me what noise I added at this one step. By training the network to predict the noise itself, not the image, the whole process just became way more effective. It's a perfect example of how a small change in focus can lead to huge results.
And here is the proof. Now, what we're looking at here is the FID score. Just think of it like a golf score for AI-generated images. The lower the number, the better the image.
Look at this. The previous best, a model called NCSN, was sitting at 25.32. The undisputed champion at the time, StyleGAN2, was at 3.26. And then this new diffusion model, the DDPM, comes in and scores a 3.17. They had officially beaten the best in the world.
That number, 3.17, was a huge deal. It was the hard data that proved this whole destroy and rebuild method wasn't just some quirky experiment. It was a legitimately world-class technique for making high-quality images. This is the result that put diffusion models on the map and basically set the stage for everything we're seeing today.
But this model wasn't just a one-trick pony. It could do way more than just make cool static images. The way it works, step by step, actually opened the door to some really fascinating new tricks. So because the image is built up over 1,000 steps, you can literally watch it emerge from the static. It's so cool. As the paper showed, the big broad things, like a person's pose or the general shape of an object, they appear first. Then as the AI keeps cleaning, the finer and finer details, like hair texture or the glint in someone's eye, get filled in. It's this incredible coarse-to-fine process that feels almost organic.
The model was also amazing at things like interpolation, where you can smoothly morph one generated face into another. And because it's so good at separating the important parts of an image, the signal, from the unimportant parts, the noise, it pointed towards a powerful new way to compress images. It showed the AI wasn't just memorizing pixels, it was gaining a real conceptual understanding of things like hairstyle and facial expression.
And on that compression idea, check this out, because this is wild. When the authors looked at how the model was actually storing information, they found that over half of it, a full 53%, was being used to describe these tiny, almost imperceptible details. Only 47% went to the main structure of the image. That means these models are naturally gifted at compression, focusing most of their brain power on the fine details we might not even notice.
So how did we get from this one pretty dense academic paper to the absolute explosion of AI art tools that we all have access to today? Well, this paper was the spark that lit the whole fire.
So, while the core theory first popped up way back in 2015, it was this 2020 paper that really showed the world what was possible. This massive leap in quality directly led to the text-to-image models that blew up a year later. The core design, and especially that predict the noise trick from this paper, became the fundamental building block for DALL-E 2, for Midjourney, and for Stable Diffusion.
And for anyone who really loves the nitty-gritty technical details, the paper makes this really elegant point. They basically say that you can think of this whole process as being like another very powerful type of generative model, but with a lot more flexibility. It's a hint at just how deep and powerful the underlying theory is, which is why it's been so successful.
So, to bring it all home, the next time you see a jaw-dropping piece of AI art, just remember the beautifully simple idea that's hiding under the hood. The AI wasn't taught how to be Picasso, it was taught how to be an expert cleaner, and in learning how to meticulously reverse a process of destruction, it unlocked an incredible power of creation.
This tech has already completely reshaped art, design, you name it. But what it's really about is teaching machines to understand the very fabric of our world by taking it apart and then putting it back together again. And that leaves us with one last, huge question. If an AI can learn to do that with pictures, what will it dream up next?